arithmetic sequences or arithmetic progression. We're looking at page 853 of our text, Pre-Calculus 7th edition. An arithmetic sequence. Definition: it is a sequence of this form: a plus b, a plus 2d, a plus 3d, and so on. The number a is the first term, d is the common difference, and it's of that form. Alright? The nth term is this. We're going to be discussing this thing over today on our whiteboard to see what it is all about. So, here now, the terms of our arithmetic sequence. They are a, then you have a plus d, then you have a plus 2d, then you have a plus 3d, you have a plus 4d, a plus 5d, and so on and so forth. Now, how do these come about? Alright. A is the first term. D is the common difference. Now, to generate this arithmetic sequence, what you do, you start with a number. Then to get the next number, you add a constant term. So you add d, you get the second number. So you have a. The next number is a plus d. Then after that, the other number would be the second one, a plus d, plus that common difference, that constant term. A plus d gives you a plus 2d. Then the next term is a plus this. It is a plus 2d, which is this you had before, plus d. This gives you a plus, let me rewrite that, a plus 2d plus d, which is a plus 3d. To get the next term, you add d. A, now remember, the term that we have now is a plus 3d, then you add d. So it becomes a plus 3d plus d, which is 3d plus 1d, becomes 4d. You have a plus 4d, you add d to get the next term, which becomes a plus 5d, and so on and so forth. Alright? Now, notice this is the first term, but it has only a1. You could rewrite it and say this is a plus 0d, a plus 0d, alright? Then you have a plus 1d. So the terms are, the first term is a plus 0d. The second term is a plus 1d. The third term is a plus 2d. The fourth term is a plus 3d. You see? 1, 2, 3, 4, 5, 6. Now, therefore, the nth term would be what? Notice, before we get the nth term, let's expand this a little bit. The first term, n is 1. How do we fit in the 1? What we have is a plus 1 minus 1 d, because 1 minus 1 is 0. This is a plus 2 minus 1 d, because 2 minus 1 is 1, and this is 1 d. You see that? This is a plus 3 minus 1 d. This one is a plus 4 minus 1 d. Good. So, ready to get the nth term? The nth term would be a plus n minus 1 d. Alright? So that is the nth term, which is what they got in your textbook. A plus, an is a plus n minus 1 d. So here now, let us look at an example with actual numbers. So remember now, the arithmetic sequence is a sequence such that you have a number, and to get the next term, you keep adding up, you add a constant, which is called the common difference. Now, suppose we are to generate an arithmetic sequence, which is also called an arithmetic progression. We have the first term equal, so the first term is 2, alright, which means that a is equal to 2, and then the common difference is, let's say, 3. Alright? Now, what we do, we start with a, which is 2. The first term is 2. Since a is equal to 2, we say 2. The next term must be 2 plus 3. Right? So this is the first, this is the second. The third term would be 2 plus 3 plus 3, which is 2 plus 6, which is 8. What is the fourth term? It was this, which was 2 plus 3 plus 3. That's what you had before. Then you plus 3. You can see that this is 2 plus 3, 3 is 9, which is 11. Now, let's look at this. You notice you can break this down into 2 plus 2 by 3, which is 2 plus 3d. This one you can break it down into 2 plus, this is 2 plus 2d. This one now, the third term is 2 plus 3d, which is 3 by 3. The fifth term would be what? It was this, 2 plus 3 plus 3 plus 3. But you get the next term by adding another 3. This now, you can call it 2 plus 1, 2, 3, 4. 4 by 3, which is 2 plus 4d. Alright? Which is 2 plus 4 by 3. Now, this amounts to 4, 3 is 12, 13, 14. So, the first 5 terms of this arithmetic sequence are 2, 2 plus 3 gives you 5. Then we have 8. Then we have 11. Then we have 14. Good. So those are the first 5 terms of the arithmetic sequence. And notice the first term is just 8, is 2. The second term, in term number 2, is 2 plus 1d, which is 2 minus 1 times the 3. Alright? Alright. Now, you were given A and D to generate the sequence. Now, let us look at another example with numbers. In this case, you are given the first few terms and you must tell what the equation is. But just before that, let's not go too far from this one. Let's do something else with it. Here, let me ask you, what is the 50th term before we do anything else? What is the 50th term? Yes, so what is the 50th term? Remember now that in general, the arithmetic progression is of the form the nth term is equal to a plus n minus 1 d. Our a is 2 and our d is 3. The 50th term n would be 1. So a50 would be a, which is 2, plus 50 minus 1 times d, which is 3. So what you get is 2 plus 49 times 3, which is 2 plus 49 times 3 is what? 3 9 is 27, 7 carry 2, 3 4 is 12, 14. 147 plus 2, which is 149. Alright? Now, let's go to that second example that I promised you. We have the first terms, the first few terms. Let us say the terms of this arithmetic sequence are 5, 2, -1, -4, -7, and it goes on and on. The question is, what is the common difference? And also, what is the format of this arithmetic progression? How do you find the nth term? So, I want D and I want AN. I also want the 30th term, which is A30, another way of writing it. So let's see. You know that A is 5. Clearly, you see the first term is 5. Now the common difference, so do you get that? Since you add a constant number to get the next term, that constant number being the common difference, what you must do to find it is take the next term, subtract it from the previous term. And you see, that's why they call it the common difference. Right? Look at this. You notice that the common difference was 3. 5 minus 2 give you 3. 8 minus 5 give you 3. 11 minus 8 gives you 3. 14 minus 11 give you 3. Just take any term minus the term before it and you get the common difference. So that's why they call it the difference, and it is common throughout. So to get D, you say D equals, you can say 2 minus 5, which is negative 3. Alright? You could also have said D equals negative 1 minus 2 to give you negative 3. You could also have said D equals negative 4 minus negative 1, which is negative 4 plus 1, which is negative 3. You could also have said D equals negative 7 minus negative 4, which would be negative 7 plus 4, which is negative 3. Any one of them minus the previous term would give you the D. Alright? Now, it's always negative 3. That is the common difference. So D is 5. D is negative 3. A is 5. D is negative 3. What is AN? Remember, AN, the nth term, is equal to the first term plus n minus 1, the position of the term, times the common difference. Now, in this case, you have 5 plus n minus 1 times the common difference is negative 3. You could write it as 5 plus negative 3 n minus 1, which would give you the same thing as 5 minus 3 times n minus 1. So that is AN. So AN is equal to 5 minus 3 n minus 1. So what is the 30th term? A30 would be 5 minus 3 times 30 minus 1, which is 5 minus 3 times 29. Alright? So that would be it. So 5 minus 3 by 29 would give you what? Negative 82 would be your answer here. So, negative 32. So, negative 82. I might say 32. So, to recap now, remember, an arithmetic progression is one in which you have a certain number, and to get the next number, or to get the next term, you add a constant to this term to get the next one. So you add a constant to the first term to get the second one. You add a constant to the second term to get the third one. That same constant you add it to the third term to get the fourth term. That same constant you add it to the fourth term to get the fifth term. And so on and so forth. Alright? So, that's what you do. Alright. So, we'll continue talking about arithmetic sequence in other videos. So, I will see you in the next video.